Hello everyone. In this video, we are going to discuss difference and similarities between DevOps and SRE. So in my last two videos, I have discussed difference between SRE and sysadmin approach to service management, and also I have discussed about what are the responsibilities of a SRE. And I will be using multiple things from the last two videos in this video. So I will repeating multiple things from my last two videos in this video, because here also I am discussing about SRE, and in those two videos I was also discussing about SRE. So I'm repeating multiple things here. So is DevOps same as SRE? So if you see in some companies, there is a job description for DevOps engineer. So they are hiring DevOps engineer. In some companies, they are hiring SRE. But if you look at the job description, most of the requirements are same for both. I mean, for the company hiring DevOps engineer and for the company hiring SRE. So it's natural to think that whether both the roles are same or not. So that's what we are going to discuss here, whether they are same or not, and if they are different, then in what ways they are different. So first we will discuss what is DevOps, then we will discuss what is SRE, and then we will try to differentiate between them and find similarities between them. So if you see the word DevOps, right, it is combination of two things, dev plus ops. So dev stands for development, and ops implies operations. So DevOps also, like SRE, tries to bridge gap between developers and operators. So if you remember when I talked about sysadmin versus SRE in my first video on SRE, so in that video I discussed about how the goals of sysadmin and SRE are conflicting. So for sysadmin, sysadmin and developers are conflicting, not between sysadmins and SRE. So sysadmin's main goal is to keep the systems stable in production, and the main goal of developers is to push the new features to customers quickly. But it has been found that 70% of the outages in production are caused by some code changes. So since code changes are causing instability to the systems, right? In this sense, the goals of developers and operators conflict. Now let's try to understand what is DevOps. So we know that okay, it's a combination of development plus operations. Now let's understand what exactly is DevOps. So DevOps is a philosophy. So it's kind of a culture which originated around 2008, and SRE is originated in 2003 at Google. So if you see, DevOps came after SRE, or the DevOps culture came after SRE. Now in this culture, what developers and the operations team. So here we do not have operations team, it's DevOps here. So development plus DevOps engineer, they try to collaborate. If you remember in sysadmin and between sysadmin and developers, there was not much collaboration. Both has different skill sets and both has different goals. And also DevOps tries to automate as much stuff as possible, so eliminating trial. And also they try to use continuous integration and continuous deployment change management approach. Now let's try to look at 5 important key pillars of DevOps philosophy. And using this philosophy, we will try to differentiate or find similarities between SRE and DevOps. So the first important pillar of this philosophy is reduce organizational silos. So what does silos mean here? Silos means in tech industry, what it means is departments with different goals, priorities, and different tools. So if you remember, there were silos initially when we were having operators and developers. So both were having different goals, different priorities, and both were using different tools. And through DevOps, we try to break these silos. So silos between developer team versus operation team. They were initially two different groups because they were having different goals, conflicting goals, as I talked about, and the tools also they use were very different. And how we can reduce these silos? We can reduce these silos by increasing collaboration between developers and the DevOps, and also making it sure that they are using the same tools. Now, the second important key pillar of this DevOps philosophy is accept failure as normal. So if you remember, for operation team, the main goal was to keep the systems stable. And if there was some failure, if let's say there was some failure of service, then it was seen as negative by the organization. And in many cases, what could happen is the developers or the operators, whoever, due to whoever mistake, the service was down, they might be punished. So that was the organizational culture before DevOps. Now, how we can accept this? How we can accept failure as normal? So how we can do this is by doing reliable testing. So before pushing code to production, we should have some testing done. Then we will also be have monitoring for detecting the failures very fast and try to recover them. So these are the philosophies here. These are key pillars here. We are not talking about the implementation part here, like how to implement this. We are just talking about the pillars here. The next important philosophy is, next important pillar is implement gradual changes. So as I told before, that 70% of the outages are caused by some code change. So how we can try to prevent, how we can basically try to prevent these outages in production. So think about this, which one is better? Pushing 1000 lines of code in one deployment versus pushing that 1000 lines of code in 10 deployments. That means 100 lines of code in each deployment. Which one is better? So see, if let's say some outages happen when you are pushing directly, let's say 1000 lines of code, then it will be very tough to debug the root cause of the issue. But if you are pushing small changes like 100 lines of code in each deployment, then it will be very easy to figure out what was the, so which code was actually, which lines of code were actually causing the issue. And also, so the approach here is to push gradual changes and also in small changes. Do not push big changes in one go, and also test it before pushing it into production. And also we should have rollback mechanism in case that let's say there was some issue. Let's say you have pushed the code to production and then there was some failure, let's say due to that code, then there should be some mechanism to roll back that code whatever you have pushed. And for this also you can use continuous integration and continuous deployment change management approach here. The fourth important pillar is leverage tool and automation. So if you remember the previous approach, sysadmin versus developers approach, in that approach it was, the writing the code was the job of the developer, and then they will give that code, they will build that code, and then they will give this to the sysadmin to deploy it. So developers didn't have the power to deploy the code. So but in DevOps approach, what we do is we give this power of deploying code directly to the production to the developers themselves. So we have some tools actually through which, so these tools are continuous integration and continuous deployment tools. These can be Git, Jenkins, Kubernetes, Mesos, Marathon. So there are various tools here, and depends on teams to team and companies to companies on which tools they want to use for themselves. So through the use of these tools, developers can directly push their code. They can make the changes, push it to Git, and then test it through some tools and build that code and test it through some tools and then directly push to the production. They do not need any DevOps involvement in that. And also tools can be used for trial reduction. So think about this, which one is better? Installing a package manually over 100, let's say you have 100 plus servers. So let's say a new package is required on all the servers. So do you manually go to those 100 servers and type the command, that is sudo apt-get install some package, try to install it, or whether you have a tool, let's say some tool, maybe kind of maybe config management tool, through which you can directly push the changes to the 100 servers directly. And also think about how do you basically check that, okay, if there are some issues happening with the services or not. Do you watch the graphs manually? So let's say you have created some dashboards for monitoring your service. Now do you watch the graphs manually? Some person sits and watches that graphs manually, versus you set up alerts on that using some tool, and then that alert goes to the on call of the service. Which one is better? Of course, I mean, you're wasting your time, right, by manually looking at the graphs. It's better to set up alerts, and when the services has some issue, that alert should fire and that should go to the on call. And this can be done using some tools. And the last and important pillar of DevOps is measure everything. So how do you know that the four pillars we talked about before are implemented successfully? So if you do not have any numbers, that simply means that no work is being done. You should have numbers to show that, okay, we have made some improvements. Without numbers, I mean, without numbers, the work, whatever you have done, right, is almost wasted. Now, what things can be measured? So take example of time taken from code changes to deployment. So as I told you, let's say before you didn't have the continuous integration and continuous deployment tools. Let's say these were not there. Now you have, let's say that you have a DevOps team, and the DevOps team has, let's say, implemented this using some tools. Now you have continuous integration and continuous deployment in the infrastructure. Now still you need to measure it, right? So before, what was the time taken from writing code to pushing to production, and what's the time taken now after doing so many changes? Another measurement can be how often do failures happen. So this can be tracked by, if you have alerts, right? If you have alerts on the services, then you can see, right, how often the alerts fires. Then how much time it takes to recover from failures. And also another measurement can be either, I mean, let's say you have a service, user facing service. So whether the number of users are increasing or decreasing, right? You need to measure all of these, right? Then all it makes sense. If you do not measure this, then you do not know what is happening with your service. Now let's look at what is SRE. So we have looked at DevOps. Now let's look at what is SRE. So SRE is what happens when you ask a software engineer to design an operations team. So this was coined by Ben Trainer. He is the founder of Google's SRE team, first SRE team. So as we talked about, that DevOps is a philosophy, right? And what SRE is an implementation of DevOps principles. That means you can think of, so we have interfaces and classes in object-oriented programming, right? In C++ or Java, you have the concept of interfaces and classes. So in interfaces, what you do is you just define the function. You just have a function prototype, right, for the function, right? You do not have the implementation for that. And then in the class, you define the function, right? So that's what DevOps and SRE is also. So DevOps is like an interface, and SRE is a class that actually implements these interfaces. So it's not compulsory to implement it's not compulsory to implement all these interfaces, right? But SREs do implement most of this. So that's why many times you will hear, I mean, in many videos or blogs, you will hear them talking about class SRE implements DevOps. Now we will see how SRE implement DevOps principle. So I told you, right, DevOps is a philosophy and SRE is an implementation. Now we will look at how SRE actually implements these principles. So first principle was reduce organizational silos. So SREs are from the computer science background, right? And also developers are from the same background. So there are no differences between them, right? Their goals also now are quite similar. I mean, to keep basically their main goal is to keep the service up and keep on pushing gradual changes, and also increase the velocity of this change, right? These are the goals for them. And SREs are also expected to do 50% of the engineering work. So if you remember, in the principles, we didn't talk about this, right? We just told that their job is to automate and everything, but we didn't talk about how to implement that. So in implementation, SREs are expected to at least do 50% engineering work, same as the engineers. But I mean, same as the developers. For developers, it's like pushing features, right? New features for customers. For SREs, the engineering work can be automation or other things. And also SREs and developers, they also use the same tools, and they also collaborate on different issues and design of the products and everything. Let's look at how the second principle is implemented by the SRE. Accept failure as normal. So SREs normally do not aim for 100% availability of the service. So what developers and SREs do is they agree on certain service level objective for their services. So service level objective I will discuss about this in later videos. But think, I mean, an example I would give is, let's say for how much time the service is actually available is one of the service level objective. So SREs do not aim for 100% uptime of the service. So let's say the example availability target can be, let's say, of the service can be 99.9%. Now if you subtract, so basically error budget is the inverse of availability target. So here the error budget will be 0.1%. So basically subtract and 100 minus 99.9. So 0.1% is the error budget. So what error budget means is that you can create that much issues. I mean, you can create, so for 0.1% of total time, let's say you are seeing time for a quarter. That means in the quarter 0.1% of the time there can be some errors, or there can be increase in latency, let's say. These issues can happen. And how developers can use this error budget is they can try to push the new features quickly. So as I told you, right, 70% of the production outages are caused by code changes. So by using this error budget, the developers can try to push the changes quickly. And if let's say if they have already so 0.1% error budget, right? Let's say if they have finished this error budget, they have exhausted this error budget of 0.1%. After that, then SREs and developers, they have to sit together and see why this is happening. Why failures are happening. That's why conduct blameless postmortem if the issues are happening. Next one is implement gradual changes. So what with SREs do is we have when a new let's say code change is pushed, then first it is tested in the staging environment, then we test it in the canary environment. So canary environment is you do not deploy directly to all the production hosts. What we do is we deploy to, let's say, 1 or 2 production hosts, and then test on that host. Then we monitor the graphs and see that okay, everything is normal. And if everything is normal, then we push the changes to all the production hosts. Similarly, if we are let's say pushing a new feature, then what we do is first we ram this feature to 10% of the users. Then we ramp it, and then after ramping to 10% of the users, we see the results, whether it is positive or negative result. And if it is positive, then we ramp it to 50% of the users. And even after 50%, if we are seeing positive results, we ramp it to the total 100% of our users. Then we have rollback mechanism to minimize impact. So even if there are some, let's say there are some issues that happens after the code change, then what we do is, let's say that code changes are deployed into production, and then we find out that there were some issues with that code. Then we have a rollback mechanism through which we roll back to the previous version of code that was stable. And also we use monitoring. So monitoring is really in all these steps, right, to detect problems quickly. And the last one is second last one is leverage tooling and automation. So for SREs also, implementing tool is an important goal for SRE also, like DevOps. But SRE should spend less than 50% of time on operational work. So since an SRE has to spend 50% time on operational work, less than this, so their main aim should be to keep on automating steps so that they spend less time on operations work. The last one is measure everything. So SREs also monitor health of the services using dashboards, metrics, graphs. So they also have everything. And we also measure the toil, because as I told, right, the amount of toil is capped at 50%, and the amount of engineering work is also capped at 50%. So we also need to keep on monitoring toil quarter by quarter. And as I talked about SLOs, right, the availability numbers, we also need to measure this, right? Then only you will know that okay, whether we are breaching this or not. So basically using metrics and dashboards, alerting, using these things, we try to monitor everything. Now let's look at, so if you see the DevOps philosophy, the 5 key pillars I mentioned, and if you see that SRE's implementation of that, so they sound quite similar, right? So DevOps is just a philosophy and SRE is an implementation. And if you see SRE is just implementing those principles, right? Then if you see their description, I mean job description also, right? Both are sounding quite similar. So let's look at if there are some differences between DevOps and SRE. Because if you see the, I mean, whatever we have talked about, it looks quite similar, right? Because DevOps are also trying to bridge gap between operators and the developers by using automation, by using continuous integration and continuous deployment, right? And using monitoring. And same things are being done by the SREs also. They are also trying to bridge the gap between the developers and the operators by using automation, by using different tools, right? So let's look at a difference. There's some difference. So let's look at a difference. So one difference, of course, that DevOps is a philosophy versus SRE is an implementation of that. So basically, DevOps tells us that what needs to be done, but SRE tells us how it needs to be done, right? Because we have the concept of SLOs, right, and error budgets we have. So we are basically defining that how the reliability can be measured, right? Exactly measured. So that was not there in the DevOps philosophy, if you see, right? It was not told how to do this, right? It was only told that what needs to be done. And also, if you see, DevOps is quite business oriented versus SRE, which is more of service oriented. Because SRE, they are trying to increase the reliability of the service that they have. I mean, and for DevOps, it is kind of business orientation, because they want to basically bridge the gap between DevOps and operators and the developers, and they try to have some infrastructure so that these gaps can be closed. So if you see DevOps delivering infra for services versus SRE, which are and whose main responsibility is to increase the reliability of the services. So if you see the SRE, right, R stands for reliability, right? And if you see DevOps, Ops is for operations, right? So I mean, whatever I have seen is that in most of the cases, the main role of the DevOps is uh, to deliver infra for the services, like having continuous integration and continuous deployment infra, so that the developers can directly push the code directly to the production. Versus for SRE, the main responsibility, if you see, is to uh, increase the reliability of their services, whichever they have. So SRE believes in the same things as DevOps, but for different reasons. So SRE, if you see, they are trying to implement the DevOps principle. So they also believe in the same things as the DevOps, but for different reasons. Because see, for CI/CD, that is continuous integration and continuous deployment, for DevOps is kind of supporting for business use case, right? Versus for SRE, it's for supporting the reliability of the service. Because if you have continuous integration, continuous deployment, right, then you can make small changes, gradual changes, right? Then you can also have a mechanism for a rollback in your CIC or CID, so CI/CD pipeline. And also you can have staging environments, canary environments, and then production environment, right? But if you see, the use case for both are different. For SRE, it's to maintain the reliability of the service. But for the DevOps, if you see, it's kind of a business oriented use case mostly, because a business wants that. I mean, they want that, okay, developers would be able to directly push the changes to the production, and this helps in pushing the changes and features quickly with the customers, right? So these are some of the differences, but in many cases you will see that DevOps are doing the same work as SRE itself, but the job title DevOps. I mean, you will see that in many cases. So the differences here are, I am just talking about what I have observed, and in many companies you will see that both are doing the same kind of work. So there is no difference at all. So, and today most companies, some have DevOps engineers, some have SREs. But SREs, if you see, they follow some kind of implementation, because SLOs in DevOps, you will not hear them talking about mostly SLOs and error budgets. But in SRE, uh, they will be talking about always about SLOs and error budgets. And mostly you will see SRE in big companies which are consumer facing, because for consumer facing you need SLOs mostly. If your company is not consumer facing, let's say, then the need for SLO is not always important. But if a company is very big and which runs at very huge scale and is consumer facing, then you need SRE. So if you see companies like Netflix or Google, LinkedIn, So they have SREs, or Microsoft. So that's all for this video, and I hope you would have understood the similarities between both of them, SRE and DevOps, and what are some differences between them. Thank you.